Hey guys, welcome back to AlgoYogi. We are doing tree series right now. Our next problem in the list is find largest value in each tree row. Let's go to the problem on LeetCode, and it's a medium level problem. So the description is just one-liner, quite really simple. So given the root of a binary tree, return an array of the largest value in each row of the tree. So as we can see, like the row by row, they mean each level. So we will be doing level order traversal, and while we are traversing one level, we just need to basically update the max value and just return the final array with all the maximum values in each row. So we'll be using BFS, breadth first search, and as we know, it will contain a queue, and initially the queue would be basically root, and then we can start appending its children to the front of the queue and then popping out the existing nodes so that we process those nodes. I like to do it a little differently. I would basically have two queues, and not like two queues independently. This initially I just have one queue. I just keep reassigning and assigning values so that at a given time I know I'm processing one level. So initially it's main queue. So this is how I'll keep it. So I'll have this queue initially with the root, and when I am processing this while loop, here I will just assign, I'll basically take the snapshot of queue and I will empty my main queue. So what this will do, and for node in queue. So this allows me to process one level at a time. So this is one level at a time. So, and here I can keep a check if a node has left child, node has right child. If they are two, then I will append them back to this queue, and it would be this queue this time, actually, not the previous one. So that this is empty now. So all the nodes. So initially, if I had root in my queue, I am assigning it to a small queue and I'm processing it using for loop. Initially, it would be just one loop, but when I'm keeping a check, if they have left child, if they have right child, these two will be together going to my queue. And next time I go to the loop, come back down here, and I process these two together because now they're part of my small queue. Now they're part of my small queue and I process them. So there is just one thing for my answer. I will have an array, and here I will have a variable called max val in current level. That is, like, let's just say -1, right? Let's just say it -1, 0, whatsoever. But then we know if we are processing these nodes and my queue was non-empty, that means I will find some maximum value in my current group of nodes, basically that level that I'm processing, and I'll update it over here while I'm checking the values while I'm inside my for loop, so that I'm not adding any more time complexity in there, right? And then I will just keep adding that to my answer once I'm out of this loop. So here I'll just keep updating this value, max value, and at the end of this for loop, when I'm out of the for loop, I'll append it to my answer and return it. So this is really quite simple, and I think this is the best approach. It will take a big of n time of complexity and a big, oh wow. Let's code a solution, and as I said, we will have queue. Initially it would be just root, and let's just say maybe we didn't have a root, so it could be just 0 number of nodes. So if root is none, then we basically return empty array. All right, because that's what we return. That's our return type. It's the list. initially we have our queue, and then now let's say we have our result array, that is the final result array that we will be returning. And let's start our BFS algorithm. So while queue, I'm taking this snapshot now of queue and assigning an empty array to my queue. Okay, and the queue would be empty. Max level, max value, let's say its max value would be, let's not call it 0, I think let's call it float infinity, so that not infinity, negative infinity, because we're looking for the maximum value, right? Because otherwise infinity would be the it would never get updated. So for node in my queue, max val would be max of node.val and my current max val, right? And that's it. If node.left, then I'll append it to my queue. So queue.append my node.left, and same thing I do with my right children. So if node.right, append node.right. All right, that's it. Now we just add my max value to my result. So that would be max val, and that's it. We just return our answer. We return our result array. Okay, let me zoom out, and I think this looks pretty good. We're iterating the node in my queue. Queue takes a snapshot of bigger queue which has root. If root is none, then we return an empty array. And here I think we're doing basically we're updating max value, and once we come out of this loop, we basically assign the max value for current level into my result. And let's run it on our examples. All right, passes the example. Let's submit it, and voila, 100%. And I think this is pretty efficient because we are not taking any extra time to basically find out what's the max value on my current level, because at the end of the day I am just checking on my current level if all the nodes in my current level, if they have left children and right children. If they do, then I'll just assign them to my main queue, and at the same time updating in constant time my max value. All right, so let's write the time complexity. So we didn't really change it, or like the problem got complicated, but we kept it big of n. So time complexity would be big of n, and space complexity is also big of n. All right, let's go back to AlgoYogi and mark this problem solved. And we are getting very, very close to finishing all the trees problem. And you guys can mention in the comment what category you would like to solve next. It could be binary tree, linked list, stack, or graph, or array string hashing. And I'm also gonna append the dynamic programming questions. They would be about like 150 questions, and that would basically make our total problems around 350 or 300 plus. All right, see you guys in the next problem.